Okay, so mine is done. So that took a few minutes for me, and it might be the same for you, or it might even that yours took less time than me. So this page can look a little bit daunting, and what I want to do is I'm going to talk you through the page and which bits that we need. So up here you've got your unknown proteins, so it's just telling you the name of the protein that you submitted. It's giving you an ID, the description, what molecule type it is, how long it is, if it's 105 amino acids long. We don't need to worry about any of this. We don't need to worry about anything except this. So this is all we need for our practical. So we're just looking at what BLAST has found us. So the top search, so this is what this is. BLAST has searched against its database using the sequence that we've inputted, and it's come up with what it's found and it's displaying it for us. So all we're interested in at the moment is the top search, as it says on our, wrong way, as it says on our practical here. So right down the top hit, this will be the one with 100% identity. Now this one here is it's saying it's cytochrome C, which is the name of the protein, and it comes from Homo sapiens, which is human. So if I click on that, it opens up this page here. And I'm just going to talk you through it. So query is the sequence that we submitted. Subject is the sequence that BLAST has found for us, so it's this sequence here. And in the middle here is, you will see later on that this will change. So this will start to show you any differences between the sequence. Now because there aren't any, it's just going to look exactly the same. But the one I'm interested in here is the identities. And gaps is also slightly interesting, which I will talk through, but identities is all we need for now. So what it's telling me is that my query sequence is 100% identical to cytochrome C found in humans. So that tells me that my protein is cytochrome C and it belongs to humans. So if we go to here, we can now write down cytochrome C, Homo sapiens. Okay, so we've now identified our mystery protein using bioinformatics. So if that's the first bioinformatics you've ever done, well done. So now we're going to move on and we're going to look at our protein sequence in terms of its evolution. So bioinformatics can help us understand the evolution of proteins. Some proteins and sequences are conserved. So a conserved protein or sequence is one that can be found in organisms that are found further back in the evolutionary tree. So for example, they're less distantly related, the organism the protein is from. This means the protein has been maintained despite millions of years of speciation and evolution. Essential proteins are very conserved, and this is because any mutation could lead to a non-viable life form, or if they survive, they are less likely to live as long and breed and pass along mutated genes. Conserved proteins include those essential for cellular functions or reproduction. So we're going to do some bioinformatics to investigate this. So we're going to go back and we're going to look further back in evolutionary history by using organisms that are less distantly related to us, and we're going to have a look at that in terms of its evolution. So let's do some bioinformatics to investigate. So using the protein sequences just identified, we're going to go back and we're going to search against different organisms. So all we need to do is scroll to the top here, and we need to click Edit and Resubmit. Okay, now within here, this is the organisms box, so we can search against specific organisms. Now we're going to use the ones that I've put here. So when I type in chimpanzee, just make sure that the name and the taxid match, and the only reason I say that is because I've made an error here. So this is actually an Australian. Go sharp, not Austrian, that's my mistake. But as long as the taxid ID matches and the name matches, then that's great. So, chimpanzee, and we'll make sure that we select the one with 9598, because that's the one that we've got here, 9598. And what we're going to do is we're just going to blast against that. So what BLAST is going to do now, it's going to take our sequence and it's going to search against the chimpanzee sequences in the database only. It's not going to look at any other organisms. Again, this might take a little while. Oh, no, it didn't. Wonderful. Okay. So if you come across predicted, we're likely to come across predicted again. Don't worry about it. For what we need it for, it really doesn't matter for our practical. We're only looking at the protein the organism comes from. It doesn't matter if it's predicted. Okay. So the top search here is cytochrome C pandroglodites, and that's obviously the scientific name for chimpanzee. So let's take a look again. So what we've got here is our query, which is our unknown sequence, which we now know is human. And we've got our subject, which is the chimpanzee sequence. So what it's telling me is that is also 100% identical, and that's wonderful. We don't need to worry about positives, and certainly not gaps for now. So what we need to do is we can now write that it's 100% identical to the human cytochrome C. So we're going to do this for some other organisms. So I'll do this with mouse for you before I leave you to it. So if we go up, edit and resubmit, and we type in mus musculus, and taxid 1090, which I believe matches. Yes, it does. And again, blast. And again, all that blast is going to do is take that sequence and search against mouse sequence only. And it's done, which is wonderful. Again, somatic, don't worry about it. That just means cells that are not involved with the germline, which are gametes, so we don't need to worry about that. We'll click on the top one. So we've got query 1, which is again what we've submitted, and we've got the mouse sequence down here, and here we have some differences. As you can see, we're starting to have the gaps here. Now, gaps doesn't mean gaps like here. We might come across gaps later on. But what this means is that instead of a P, we've got an A. So here it's all identical. Here this is a positive, but we don't need to worry about that. It's just an S to an A, an M to a Q. All I'm interested in is how identical it is. So it's 91% identical, which means that all of this sequence here is 91% identical to the mouse sequence. So what we can do is we can go back and type in 91% identical. And what I want you to do is I want you to work down all of these organisms, and I want you to type in their percentage identity. Okay? Now, with some of these, they might look a little bit odd. So what I've done is I've taken organisms that are more and more distantly related to us. So some of these you might not have heard of. And if you do want to find out what organisms you actually are looking against, feel free to copy and paste their names into Google and learn a little bit more about them. It might be interesting, especially for you, to look a little bit this one. So I've thrown this one in just as a really cool example, really. So I will come back to this in another video. For now, I will let you carry on with the blasting of your sequences, and I will see you in the next video, guys.